So what we need to do is get the refrigerant from our service port on the unit to the port on our manifold gauge set so that we can read pressure and convert that to a saturated temperature. It sounds pretty straightforward, but there are some laws involved with this, some safety measures involved with this, and some curveballs that sometimes new technicians get hung up with. So let's go over this. First, let's talk about the hose that we have. So here's the hose we have, and there's two different kinds of ends over here. So if you look at the end, one of these has something in the very center of it, whereas the other one is completely hollow. The one that's completely hollow is what's going to attach to our manifold gauge set. So in our manifold gauge set, we have two different ports. One is where a hose hooks to, and the other one is going to be where we hold the other end of the hose. The one that's always straight down is where we're going to hook the hose to. So in this case, we hook the hose like this. Now our pressure can flow through here to our manifold gauge set, to our pressure. The other side is just to hold the other end when we're not using it. Now sometimes I've seen students before get mixed up, and it happens, but they'll put the port here and there's nothing allowing pressure to come through. So they're thinking, hey, there's a problem with this unit. And it's really not the unit, just got to make sure you put it on the right side. So I want to make sure you got this down before you go to your first practice unit or before you get your first job or apprenticeship, whatever it is, so you don't make that same mistake. So now that we have that side hooked up, we're going to look at the other side. So this fitting is called a low loss fitting. We're going to come back to that shortly, but in the very, very, very center, you see that there's what looks kind of like a little button right there. And that is very important because what we have is our service port also has a little valve inside of there. So the little center part of this piece is going to press on the center part of that piece. What we're going to do is pull that piece out so you can see exactly what it looks like. So here is the guts of the Schrader core. If you look, it's very similar to a car tire. And if we push in on this port, you can see how it opens and closes. It's a very simple little process, but it's very important because it keeps the refrigerant inside of this unit. When we thread this fitting on, it allows that port to be pressed. So we thread this on. This allows the port to be pressed. Refrigerant flows from here through the hose to our manifold gauge set. Very important process. Now also, there's another valve inside of this fitting, which is called a low loss fitting. So when we unscrew this valve, there'll be a little noise, and the refrigerant's locked in here. There's also a valve here that locks the refrigerant into this side. Now I've used, on this example, a suction gauge. It's a low pressure hose. There's only low pressure vapor. So if we were to loosen this and allow the refrigerant to escape, it's really not that big of a deal. The problem is when we use the liquid side. The liquid side, let's talk about the high pressure hose. So if we use the high pressure hose and hook it up to the high pressure side, there's going to be liquid refrigerant in this hose. High temperature, high pressure, subcooled liquid. If we were to take this fitting off and it didn't have a low loss fitting, liquid refrigerant would flow out of the hose onto our hands and we'd have a major loss of refrigerant. We'd be losing the customer's refrigerant. We'd have an EPA violation, as well as you would have severe frostbite on your hands. Do a little Google search to see what frostbite from refrigerant looks like. The hand looks like it's boiling. It's this really, really, really disgusting. So different types of low loss fittings, and we must make sure we have a low loss fitting at least on the high side, preferably on the high side and also the low side. So let's first look and see how do we identify a low loss fitting. Usually if you look on the very back side of the unit, you see this type of keeper ring back here. That's very, very important. This fitting is not a low loss fitting. And if we see that there is no keeper ring and this piece moves freely back and forth, this is not a low loss fitting. This should not be used directly onto an HVAC unit. It still has the Schrader depressor in there, but there's no valve built into this. This one does not move back and forth. Easiest way to identify is use that little keeper ring. So this is what we want to use. We want to stay away from this style right here. Now, this is a newer style, but they make a few other types. The older ones we had were a little bit larger, but it still had that same keeper ring, a little bit large in diameter. And here's another model that's a lot smaller, but it still has that keeper ring. These are low loss fittings, and they're actually rebuildable, so you can take these apart and rebuild them. There is also this style. Now I have my students start off with the one we talked about first. It's an automatic low loss fitting. But this style here is also very well used, and it's actually my favorite. When you put the valve on, it has a standard size end. We screw this on, Now we have to manually open this valve to allow the refrigerant to flow through a manifold gauge set. When we're done, we have to remember to shut this off before we take this hose off so that we don't lose the refrigerant in this hose. For new students, this is a few extra steps, but once you get a little bit of time in your belt in the career, this is really what you're going to want. Because when you open this valve, it's a full flow. Refrigerant flows through here fast, which is really important when we do vacuum and recovery. This one is going to slow the refrigerant flow down. It's fine for all of your typical service work, but if you're doing a recovery through here, this is going to slow the flow down, whereas this one makes it faster. I prefer this one, but whatever you feel more comfortable with over time, and you can always switch from one to the other. Now, unfortunately, a lot of the hoses that they're selling nowadays do not have low loss fittings, such as this one does not have a low loss fitting. There is a solution for it, and one of the solutions is you can actually purchase a standalone low loss fitting. You can see it has that keeper ring on it, and then from there we can thread this on to our existing hose. Now we have a low loss fitting, which is allowed by the EPA. If we take the low loss fitting off, this is not allowed to be used by the EPA. On top of that liquid refrigerant coming out that we're losing from the customer, on top of it potentially hurting our hands. So if we put this fitting on here, it now makes it EPA certified. The problem is that I found is when you're working with units and you're trying to screw this fitting on or off, over time these will get loose and can come loose and spray refrigerant out. Also, I've seen an issue with students before that didn't yet have enough experience under their belt. They would put this onto the unit, and then when they go to take it off of the unit, they unscrew this one first. When you unscrew this one first, all the refrigerant out of the hose comes flooding out, as well as, since the Schrader's depressed, all the refrigerant from the unit comes spraying out as well, and they have refrigerant spraying out from both sides. They don't know what to do. That's why I personally don't like this style, but it is an option. Now, some other options are you can add a valve style to that same hose. So I can thread this on here. Now I have a valve that I can manually control, and we take this off of the service port, and it gives us a little bit of room to play with. Some people prefer that because this one's really close. This one gives us a little bit more room to get into tighter areas. And some other brands that look very similar to that. Here's another one, has a little different type of valve, and yet another one with a little different type of valve. But they all work the same way. We want to prevent loss of refrigerant coming out of the hose, and we want to make sure that we don't hurt your hands when you're working with this. Now, another thing to be very careful about, be mindful about, is when you're to this port. A lot of technicians develop bad habits, myself included, and you want to grab the hose like this because you have control and you can turn the knob. There is a problem with that. If we're doing it like this and there becomes a problem in here, let's say dirt or something gets in here, this will allow refrigerant to spray two directions. One will be coming this way and the other one will be coming this way. So if refrigerant's spreading out this way, it's going to spray liquid refrigerant to the palm of my hand, and that's going to be a very bad day. So we want to make sure we always use two fingers like this. So if refrigerant comes out this way, we're clear, or if refrigerant comes out this way, we're clear. Or we can do it like this, or we can do it like this, or any other combination, but make sure your hands are clear from this side and that they're clear from this side, so that when you're taking these fittings on and off, there's no chance of you getting burned. Now, on that same topic, there are some gloves to wear. The problem is these are butyl-lined gloves. They're very thick to work with, and these gloves do not absorb any kind of liquid, such as liquid refrigerant. A lot of new technicians will just try to use their regular mechanics gloves or cotton gloves or any kind of material gloves. Well, the problem is that material will soak up the liquid refrigerant. So now your hand has liquid refrigerant on it. That liquid refrigerant boils into a vapor, and it literally freezes the glove to your hand, and you cannot get your hand out of the glove. So if you want to use gloves, you have to make sure you use the refrigerant rated gloves. You can't just use any type of glove. Me personally, I know it's not OSHA certified, but if you use your two fingers the right way, I've never been burned by refrigerant in my life. But it's taking those extra precautions. So a few more things we want to talk about. If we're talking about using a digital gauge set, such as this, and there's no hose to use, we can use a T-fitting. In other words, we're going to take a fitting like this, and we screw this fitting onto the unit, and then we can use our digital gauge set right onto this fitting. So now if I need to charge or recover refrigerant, I can use this hose to my side port here, and I can hook the other side of this hose straight to my recovery tank or my refrigerant tank. And I can now control the flow of refrigerant in and out of the unit just like we can with our manifold gauge sets. And we're going to be doing this live later on through this course. Just know that there's a way to use a probe or a system of charging without having to use the manifold gauge set. So let's just do a quick little recap. You want to make sure you have some kind of low loss fitting, whether it be a valve or an automatic low loss fitting. You may want to make sure you do not have one of these style that has play in it directly onto the unit, because you could burn your hands and it's an EPA violation. Furthermore, they also make different adapters. Some of the ductless units we're working with now have a different size fitting. All of these are 1/4 inch SAE fittings, but some of the new ductless units use a 5/16 fittings. We can actually get an adapter and we can adapt our fittings to these other fittings. So some of the 410A systems, you'll see it. When we get there, we'll talk about it in more detail, but it's nice to have these adapters when you come across that scenario. Also, if you're doing automotive work, there's a different type of adapter that you use. They have the quick connect adapters for all the new 134A systems. And you can also get adapters for these hoses where you can use from these type of refrigerant ports to our manifold gauge set. So there's tons of different adapters and options you can work with. One last thing let's talk about is the hose itself. So if we take a look at these hoses, we can see that they are double layered. There is inside layer and an outside layer. We want to make sure that these hoses are in good shape, they're not leaking. If they are leaking, like this one was, you want to make sure that you cut it so you don't accidentally end up using it in the future or that nobody else uses it. Another thing that's important about these is the pressure rating. This one's set up for a 4,000 PSI burst and an 800 PSI operating pressure. That's very important, and that will handle our 410A refrigerants as well as our other lower pressure refrigerants. But some of the hoses that we work with, they'll actually have a much lower rating. So this one says R12, R134A, and it actually has a pressure rating of 2,500 PSI burst, working pressure of 500 PSI. So if you tried using this hose on a 410A system, you could actually have it blow out on you. The reason that's important is sometimes people try to save money by buying a cheaper hose online, but those cheaper hoses may not be rated for that higher rating that we need with 410A refrigerants. Low loss fittings, whether it's automatic or manual, make sure you have the right connection to the gauge set. There's tons of adapters we can use for just about any scenario. Make sure it's rated for the right pressure. Cut old hoses. Be safe. Next video, we're going to be hooking them up to the unit.